Okay, we're back for part 3 of the lesson. Alright, hopefully you have time to try this. If not, please pause and try it first. Alright, 2-point charges are situated at these 2 points. Right, one is -2q, one is q. Which point could the resultant electric field due to these charges be 0? Right, hopefully you can see there are 3 clear areas that we talk about. We can look at this region 1, this region 2, and this region 3. Our first job is to actually see whether which region is it possible for the resultant field to be 0, right? So we must remember that a negative charge, which is -2q, the field is always inwards, right? So in region 1 is towards the right, right? For positive charge, which is this one, right, the field is always outwards, right? So I just draw here. So in region 1 is this direction, right? So the first thing we know is that region 1, can the electric field be 0 due to direction? The answer is possible. Right, if we look at region 2, which is these 2 vectors over here, can the region be 0? Answer is no, because they are in the same direction, they must sum, right? Finally, in region 3, let me check for the -2q, because you extend this, you realize that it's in this direction. So this part also possible, right? So the answer must lie between region 1 and region 3, which means it's either A or D now, right? But if we look at region A, right, you realize that this vector is from the -2q and this vector is from q. And the electric field strength is 1 over 4 pi epsilon naught q over r squared, right? Right, if we look at this term, can you see that in region 1, the -2q will always be stronger than the q? Because if I look at -2q, number 1, the charge is bigger, right? It's twice the charge of plus q, and the distance from the charge is smaller. So the combination of these 2 factors means that the electric field due to the -2q charge will forever be greater than the plus q charge. And therefore, this vector over here will always be bigger than this. And therefore, region 1 is actually not correct from a magnitude standpoint. Right? So from magnitude standpoint, region 1 -2q will be always stronger than q. And obviously, if you look at the other side, vice versa in region 3, it's possible because if I look at the small q, the positive q versus -2q, let's look at the positive q. So same formula, but if I do a comparison here, q over r squared in region 3, you realize that uh, positive q will have a smaller r, because it's closer to this side as opposed to this charge. All right, so this is the R for positive Q, this is the R for 2Q. And so therefore, even though it has smaller charge, it is possible for this one to be equal to the -2Q charge electric field in this side. Right, so answer should be region 3, and therefore the only possible answer is D. And right, you can pause and read the solution if you wish to. Right, we'll move on to 7. All right, 7, yeah, and 7, please pause and try yourself. Okay, we are back from the pause. Okay, there are 2 charges, -q and +2q. All right, their distance 10 cm apart. What's the direction of the electric field strength at D at the midpoint? All right, so I try and figure out the field strength at D due to +2q and -q. All right, so I draw a diagram. All right, so try and draw a diagram like that. Right, clearly E2 is from this one, which is bigger because equal distance, but this is a bigger charge. Right, so this is a bigger charge than this, and remember that electric field and force are both vectors, so you must vector sum. Right, but in this case, the vectors are in exactly the same direction, so I just sum the magnitudes will do. But remember, E field must vector sum. Right, so if I just do the substitution, 1 over 4 pi epsilon naught q over r squared, 1 over 4 pi epsilon naught q over r squared. Right, and that sums to give me the total electric field here as 1.08 times 10 to the power 6 Newton per Coulomb. Right, direction is towards the left. Right, because positive charge is outwards and negative charge is inwards. Right, so that's why both E1 and E2 are towards the left. Right, then we want to look at the second case, electric field strength A. Now A is a bit more complex. Again, please draw the diagram. Right, so if you draw the diagram properly, it will look like that. Remember, positive charge is out and negative charge is in. So if we compare the out and in, you realize they are the same distance apart. Right, but again, plus 2Q is a bigger charge than minus Q, right? So if I look at E4, which is the larger field, right, is double the charge of this, right, divided by 4 pi epsilon naught R squared, right? Okay, I think there's something wrong with this working here. Sorry, this one should be 10 to the power of minus 2 bracket square. So it should look like that. Okay, sorry about this. I'll correct this later. Right, and of course, E3 here towards the minus Q charge, you can calculate as this one. Right, so this version is correct. This version is wrong. There's something wrong here. I'll go and change this later. Right, and you should realize that this charge is bigger. This electric field strength is bigger than this one. And I have to vector sum. Okay, please do not scalar sum these two things. They are vectors and they are not in the same direction. You have to vector sum. So normally what we do is resolution, right? So we want horizontal components to sum and vertical components to sum. Horizontally, E4, right, with this angle here, 60 degrees, right? So why negative is because I take right to be positive lah. So negative E4 cos 60 degrees, which is the resolution on E4 in this direction, right? So this is E4 cos 60 degrees. Negative because I take this direction to be positive, right? And of course, if I resolve the other way, is this one lah. E4 sine 60 degrees, right? Then E3, same thing, right? E3 cos 60 negative, E3 sine 60, alright? So negative E4 cos 60, negative E3 cos 60, that should sum to give you this value over here. And vertically, you take upward as positive lah. So E4 sine 60 minus E3 sine 60, you get this one, right? Then you have to sum these two because this is just the components of the resultant, right? So Pythagoras theorem, you should be familiar with this and find the angle between them, alright? So the resultant angle between these two is, so I'll draw it for you lah. This one is this direction, 1.3488 times 10 to the power 5, and vertical is like that, 7.785 times 10 to the power 4. Right, sorry about that. Right, so this is my resultant. Right, and the angle tangent theta is opposite. Oh yeah, so they took this as theta. Right, anti-clockwise from the left. Right, so that's why it's anti-clockwise from the left. Right, moving on. The force is easy. Right, to find force, you just take the charge times the resultant electric field strength. Right, for both. Right, obviously the force is same direction as the resultant field. Okay, likewise with for A and B lah. Okay, so I don't think this one is a big problem for you. Right, let's move